So division of polynomials works very similar to division of whole numbers. So we're just going to review the standard algorithm for dividing two whole numbers. So we're going to do it the standard way, and then we're going to do it this other way where we write everything by place value. So instead of writing 21, we write 20 plus 1, like 2 10s plus 1. And here we're going to write 700s plus 3 10s plus 7 1s. Okay, so old division algorithm, you probably learned this sometime in elementary school and may have forgotten it, so we're going to review. So you look at the 21, and then you look at the first however many digits that you need for the 21 to be able to go into it, right? So I'm going to look at the 73. So how many times do you think this 21 goes into 73? 3 times. 3 times. So we put a 3 above the 3. Because really what we're saying is that 21 goes into 730 30 times. At least, yeah. So then you multiply the 3 times the 21 and you get 63 and you subtract, right? And we get 10. And then you bring down the 7. Does this look familiar? Okay. Then you say, okay, how many times does 21 go into 107? 5 times. So you write the 5 up here above the 1. And then you have 5 times 21 is 105. And you subtract. And we get 2 as the remainder. How do we know that? Yeah, you can write R. Right, yeah. So in elementary school for a long time, you write remainder 2, right? And then eventually you learn that you can also put this as 2 over 21, the fractional part. Well, there you go. So if there's 2 left over, that means that 21, how many times does 21 go into 737? Well, 35 whole times and 2 21sts of a time. That's the fractional piece. All right, so now we're going to do the same problem, but we're doing it in a slightly different algorithm that uses place value. So we were using place value over there, but it's like so deeply ingrained in us that we don't even really see that that's what we're doing. So I'm just going to write it out the long way here. So I wrote 21 as 20 plus 1 and 737 as 700 plus 30 plus 7. So I'm grouping it by place value. So now, instead of saying 21 into 73, I'm just going to look at the 20 and the 700. How many times does 20 go into 700? 30. Good. I know, but I'm trying to mirror what I did over there. So 30. All right, so then you have to multiply 30 times the 21, right? But because I wrote it as 20 plus 1, you have to distribute, right? 30 times 20 plus 30 times 1. So 30 times 20 is 600, right? And then 30 times 1 is 30. And then I subtract. So when I have a 600 plus a 30, that over here, that was represented as a 63. But because I was in the hundreds place and the tens place, that is really 630. All right, so when I subtract, I have to subtract each of them. 700 minus 600 is 100. And 30 minus 30 is 0. And then you bring down the 7. And then you say, okay, how many times does 20 go into 100? 5 times. So I put my 5 over the ones place. 20 times 5 is a 100. 5 times 1 is 5. 0 tens, right? And when I subtract, I have to do 100 minus 100. That's 0. 0 minus 0 is 0. And 7 minus 5 is 2. So I end up with 30 plus 5 plus 2 over 21, which is 35 and 2 21sts. Same result. All right, so to check your work of any division problem, you can multiply your divisor. So I should label these things. This is the divisor, right? The thing you're dividing by. The answer, the whole part of the answer is the quotient. And this guy is the dividend, and this guy is the remainder. So to check your answer to a division problem, you should check that your divisor times your quotient plus your remainder gives you the dividend back. So my divisor is 21 times my quotient, which is 35, plus my remainder of 2. That should equal 737, the original dividend. So 21 times 35, that's 700. Well, 35 times 20 would be 700. And then plus 35 was 735, plus 2 is 737. So that is true. You could just use a calculator to check it if you want. Yes, just plus the plain old remainder, not the fractional. So 21 times 35 plus 2 gives you the 737. Same check over here. These numbers are all the same, so I won't do it again. All right, so we've had a nice thorough review of long division. Now we're going to talk about how to use long division to divide polynomials. So I've got a whole list of steps, what to do on the right. We're going to do them here on the left. So I want to divide 6x squared plus 5x minus 6 by 2x plus 3. So the way that this is related to division of real numbers is think of the x like a 10, right? So this would be 10 squared, which is 100, right? So this would be like 600s. This would be like 50, and this would be minus 6. And then this would be like the number 23, 2 10s plus a 3. So think of your x as the same, working the same way as your 10s did, as your place values did with real numbers. So this is equivalent to doing 644 divided by 23. So each term is like place value in regular division. So first you want to arrange it so that the highest powers of x are first and in descending, put them in descending order. So it's like hundreds, tens, ones, just like we do with whole numbers. Or thousands, hundreds, tens, ones, yeah. And the same thing with your divisor. You also want to put that in descending powers of x. All right, and then we write out our division. So we do 6x squared plus 5x minus 6 divided by 2x plus 3. Okay, so then you look at the leading terms in your dividend and your divisor, and we have 6x squared and 2x. Divide them, right? What is 6x squared divided by 2x? 3x, right? 6x squared divided by 2x. 6 over 2 gives 3, and x squared over x, you subtract the exponents and you get an x. The other way to think about it is to say, what should I multiply 2x by to make a 6x squared, right? Just an alternate way to do a division problem. And you would say, oh, well, 3x. And I'm going to line up my 3x with the term that it's like, right, in the dividend. Okay. So now I've got my 3x up here, and then you have to multiply it by your divisor. So you have to distribute it to the 2x and the 3. So you have 3x times 2x is 6x squared, and then 3x times 3 is 9x. And then you have to subtract both terms, so minus, minus. So 6x squared minus 6x squared is 0. This drops out, right? And then you have 5x minus 9x, which is negative 4x, and then you bring down the minus 6. Right, okay, so the next thing I want to do is I want to divide my leading term of negative 4x minus 6 by 2x. Or alternatively, ask yourself, what should I multiply 2x by to make a negative 4x? Negative 2. So I put a minus 2 there, and I line it up with the like term in the divisor, so I put it over the minus 6. Then you have to distribute this minus 2 to both terms in your divisor. Minus 2 times 2x is minus 4x. Minus 2 times 3 is minus 6. Then you have to subtract both of these, minus, minus. And you get negative 4x minus negative 4x is 0. Negative 6 minus negative 6 is 0. Negative 6 minus negative 6 is like negative 6 plus 6, right? Minus a negative changes to a plus. So what does it mean that if I have a remainder of 0? Right, this is the answer. There's no remainder. So it means that 2x plus 3 went evenly, right, into this divisor of, dividend of 6x squared plus 5x minus 6. And I got 3x minus 2, right? So I should be able to check this by multiplying my divisor by my quotient and getting my dividend. Yeah. Yes, it's going to help us factor. Yeah. So if you know one factor, you can get another factor by using division. Just like with regular numbers. Like if I said, okay, I know that 30 has a factor of 6, but how could I figure out the other factor? Just do 30 divided by 6 and you get 5. Oh yeah, 5 times 6 is 30. Right? So if you have one factor, you can get another by using division. So now this means that I can write my dividend as a product of two factors, 2x plus 3 and 3x minus 2. And I should be able to check that by foiling, right? So if I FOIL those out, I get 2x times 3x is 6x squared, minus 4x plus 9x is plus 5x minus 6. Checks out. So yes. What? When you have a quadratic, right, it is not better than factoring. Because if you can factor it in your head, or by using, whatever method you've used for the past 2 or 3 semesters that you've known how to factor, go ahead and do that, right? Why learn something new? But yeah, but if this dividend is like an x cubed or an x to the 4th, factoring now becomes really difficult. So if you know one factor, right, then you can divide to get another, right? And how might you know one factor? How could we figure out one factor of a polynomial? If you know 1, 0, you know one factor, right? 2 for the price of 1. And then you can find zeros by like looking at the graph and getting an x-intercept. So we're gonna be developing this hybrid approach to factoring where we get zeros by using the graphing calculator. And then you have 2 for the price of 1. If you have a 0, you have a factor. And then you can divide using long division to see what another factor is. And then you repeat the process until you have all the zeros and or all the factors. But today, we're mostly focusing on this process of long division. Okay. Tomorrow, or Friday, we'll be pulling it all together to use it for factoring. All right, so I'm going to have you try one. I'm just going to give you one little hint. Well, actually, I already told you this, so I shouldn't have to tell you again, but I'm going to. Rewrite these in descending powers of x. So this is going to be 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2. So you now have a cubic. This would be difficult to factor. So we're going to use division to find another factor. Okay, so let's go through it. So first step is to divide your leading terms, right? Take your 6x cubed and divide by 3x. So you can write it out on the side if you want. You can say, oh, 6x cubed divided by 3x. 6 over 3 is 2. X cubed over x is x squared, right? Or you can ask yourself, what do I need to multiply 3x by to make 6x cubed? This is the same question, right? Undoing division is multiplication. So 3x times 2x squared gives me 6x cubed. So I put my 2x squared over the x squared term in the dividend. And then I have to multiply my 2x squared times the divisor, so I'm going to have to distribute. So 2x squared times 3x is 6x cubed, and 2x squared times negative 2 is negative 4x squared. Now I have to subtract. And I have to subtract both terms, right? So I have to subtract from this term this whole thing, right? So sometimes it helps to think about distributing the negative. So 6x cubed minus 6x cubed is 0, right? So those cancel. And then you have negative x squared minus negative 4x squared. So that's negative x squared plus 4x squared, which is 3x squared. Bring down the minus 5x. I saw several people also bringing down the 4. It's fine. You can do that too. All right, so now you ask yourself, what do you multiply 3x by to make a 3x squared? X. Yeah, 1x. So I put plus x. Line it up over the x term in the dividend. And then multiply. X times 3x is 3x squared. And x times negative 2 is minus 2x. And then subtract the whole thing. Okay, so 3x squared minus 3x squared, those go away. And then you have negative 5x minus negative 2x, negative 3x. Bring down the plus 4. Okay. Lastly, just do the whole process again. What do you multiply 3x by to make negative 3x? Negative 1. Okay. So then negative 1 times 3x is negative 3x. Negative 1 times negative 2 is plus 2. And you subtract minus this whole thing. And negative 3x minus negative 3x, those cancel. 4 minus 2 is 2. So I have a remainder, right? I have a remainder this time. So the way you deal with the remainder is you write plus, and you put the remainder over the divisor. 2 over 3x minus 2, just like you do with regular numbers. Okay, and then I can write this, right? If I wanted to check it, I would say my divisor. So I'm just going to do it in a different color over here. So I should be able to multiply 3x minus 2, my divisor, times my quotient, 2x squared plus x minus 1, and add my remainder, 2. That should give me my original divisor, the 6x cubed polynomial. Minus x squared minus 5x plus 4. So you can check by multiplying this out, right? Simplifying the left-hand side. Are these equal? Is how you check. Divisor times quotient plus remainder should equal dividend. Let's actually multiply it and see that it works. So how do you multiply? So we very frequently multiply a binomial by a binomial when you have 2 terms times another thing with 2 terms. What if you have 2 terms times 3 terms? Is there a special word? Like we use FOIL to do 2 by 2. Is there a special word for 2 terms times 3 terms? No. Yes, it's just like foiling. Make sure you hit all the inside terms. That's a good way to describe it. The rule is multiply everything by everything else, right? So I'm going to start with my 3x and multiply it by everything else in the other set of parentheses. So 3x times 2x squared is 6x cubed. 3x times x is 3x squared. And 3x times -1 is minus 3x. Okay, so I've distributed my 3x to every term in the other parentheses. Now distribute your -2. And we have -4x squared minus 2x plus 2. And then I still have this plus 2 over from over there. Combine like terms, and I have 6x cubed. 3x squared minus 4x squared is -x squared. -3x minus 2x is -5x. And 2 and 2 is 4. And that is the dividend I started with. So that's all that this, oh, it didn't print on mine. Division algorithm says that your dividend is equal to your divisor times your quotient plus your remainder. It's just a convenient way to check your division. Okay, one word of warning. We're not going to do this whole problem here, but I just want to point out, if you have a polynomial that doesn't have every power of x, right, like x cubed plus 1, doesn't have an x squared term or an x term, when you're doing the division algorithm, you should add them in with zeros. Just like if I was dividing, 107 by, yeah, this is 1, 100, 0, 10s, and 1, 7. We use a 0 placeholder to do the division algorithm. So when I have an x cubed plus 1, I should write x cubed plus 0x squared plus 0x plus 1. And use those as placeholders. And then I'm going to divide that by x plus 1. And then the algorithm proceeds just like it did in the previous two examples. Let's see how much there's left here. Oh, enough that I think that we should probably skip this. So we're not going to do all this algorithm out for a third time. Okay, so now we're going to talk about what does this have to do with factoring, right? Because many of you recognize that this has to do with factoring, doing this division. Okay, so suppose that a polynomial function has zeros at -2, 1, and 3, like in this picture. What do you know? Then what are the factors of this function? Right? If you know it has zeros at -2, 1, and 3, what do its factors have to be? Yeah, x plus 2, x minus -2, x minus 1, and x minus 3. Right? 2 for the price of 1. If you know a 0, you know a factor. And often, instead of writing x minus -2, you'd write x plus 2. But I'll just leave it like that for now. All right, so if x plus 2 is a factor, then that means -2 is a 0. And that means f of -2 equals 0. That's what it means to be a 0 of a function. It means that when you plug it in, you get 0. And if x minus 1 is a factor, what does that tell you? F of what equals 0? 1. That means 1 is a 0 of that function. And if x minus 3 is a factor, then f of 3 is 0. 3 is a 0. And vice versa, right? If f of -2 is 0, you know x plus 2 is a factor. And if f of 1 is 0, you know x minus 1 is a factor. And if f of 3 is 0, then you know x minus 3 is a factor of the function f. So this is something called the factor theorem. And we've been building up to it and using it for the past several classes. But here it is officially. It says if f of c equals 0, that is c is a 0 of the function, x minus c is a factor. And if x minus c is a factor, then f of c equals 0. F of -2? right here? Which one? F of 3? Yeah, so think about this. If I have a factor and I set it equal to 0 and I got x equals 3 as the answer, what had to be over here on the left side of the equation? X minus 3. So if you know, this means that 3 is a 0, right? Which means that x minus 3 had to have been a factor. Because they told me that 3 is a 0. They told me positive 3 is a 0. So if I plug 3 in, I should get 0 out. Okay. All right, and then take a look at this graph. So I now know it has these 3 factors, right? Which means it's probably a cubic, because if I multiplied those all together, I'd get an x cubed. The thing I don't know anything about right now is the leading coefficient a. Although that's not quite true. I know a little bit. How do you know it's positive? And behavior, right? I know a has to be positive. A is positive because I have right arm up, left arm down. So it's a cubic, odd degree, and right arm up, left arm down means A has to be positive. Good. All right, so I'm going to use the factor theorem here. I have this equation that I want to solve for x. I have 2x cubed minus 3x squared minus 11x plus 6 equals 0. And I already know one of the solutions, right? I already know negative 2 is a 0. There's some mistakes in here. Of f of x equals, there we go. Okay, so I know that negative 2 is a 0 of that function that's on the left side of the equation. So given that negative 2 is a 0, then by the factor term, what does f of negative 2 equal? 0. Yeah. If negative 2 is a 0, that means that f of negative 2 equals 0. That's what it means to be a 0. And x plus 2 is a factor. Use long division to find the other factors of f of x. Right, so I want to do, I know I was given a 0, which means I know a factor, 2 for 1. To find another factor, I use long division. I'm going to do 2x cubed minus 3x squared minus 11x plus 6. Divide by x plus 2. Do out the division. What do you multiply x by to make a 2x cubed? 2x squared. So I put that over the x squared term in the dividend. Multiply your 2x squared by your divisor, so you get 2x cubed plus 4x squared, and subtract. So 2x cubed minus 2x cubed is 0. Those go away. Then you have negative 3x squared minus 4x squared, negative 7x squared. Bring down the negative 11x. What do you multiply x by to make a negative 7x squared? Negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. Subtract. And the first terms cancel out. And then you have negative 11x minus negative 14x, just 3x. Bring down the plus 6. What do you multiply x by to make 3x? 3. Multiply your 3 times your divisor, and you get 3x plus 6. Subtract, and you get 0. No remainder. So that means I can write 2x cubed minus 3x squared minus 11x plus 6. I'm trying to solve that thing equals 0. Because I was given a 0 of negative 2, I knew that one of my factors was x plus 2. And now I know the other factor is 2x squared minus 7x plus 3. So now I have a multiplication problem. I have two things being multiplied together and the answer is 0. So I can set each one to 0 separately. Say either x plus 2 equals 0 or 2x squared minus 7x plus 3 equals 0. This one I get x equals -2, which I already knew because they told me -2 was a 0. How would I solve this one? Factor it or use a quadratic formula. Can I factor that? Two x and x. Thinking +1. Oh, so it's going to have to be minus minus to get a negative on the inside and a positive on the outside. So I'm thinking -1 minus 3. 2x squared minus 6x minus x. Yeah, there we go. So we get x equals 1/2 or 3 are my two other solutions. Whew, yeah. All right, last one. I'm going to erase this last bit here so we can see the graph. All right, I want to write a possible equation for this graph. So let's start by listing its zeros. Where are the zeros here? -2, 0, and 1. Good. Those are the x-intercepts, right? What's the multiplicity on the 1? Even. So if I want to be as simple as possible, I'll say it's 2. Possible multiplicity of 2. How about on the 0? What's its multiplicity? 1. It just goes right through the axis, which means it's odd. And to be as simple as possible, we'll give it a 1. How about the multiplicity on the 2? Also odd, but it looks like a cubic when you go through, right? The way it flattens out. So that is an indication that it's a 3 multiplicity. Because it flattens out and stalls as it goes through the axis, that indicates that it's multiplicity 3 as opposed to 1. 3, 4, 5, 6. Yeah, the degree is 6. And that makes sense with the end behavior, right? With both arms up. It's got to be an even degree. So let's see, I would have y equals, I've got some leading coefficient, I don't know what it is. And then I have these zeros, which means that each 0 corresponds to a factor, right? X equals -2 corresponds to what factor? X plus 2. And I'm going to raise it to the third because it's multiplicity 3. Yep. And then x equals 0, that corresponds to a factor of x or x minus 0, right? And it's going to be raised to the first power because it's multiplicity 1. And then x equals 1 corresponds to a factor of x minus 1. And because it's multiplicity 2, it's going to be squared. And then I don't know what the value of a, but what do I know about a? Positive because both arms are up. So I know this has to be some positive number. Yeah, sure.
Isn't that like both sides are like starts off negative?
Like this, opposite end behavior, that's when you have an odd degree. Yeah. So the degree of this guy, because if I were to multiply this all out, the highest power in this term would be an x cubed. Then when I multiply by an x, I'd get an x to the 4th. And then the highest power in this factor is an x squared. So x to the 4th times x squared would be x to the 6th. So this whole thing is degree 6, which means either both arms are up or both arms are down. Yep, opposite end behavior. And I would have to have one fewer 0. Mm-hmm. Yeah, you can also just add the exponents. Yeah. Yeah, because when you multiply like bases, you add the exponents. So you're just jumping to the rule. Yeah. All right, so that's good. We do not have time to do this activity. I'm going to give you your quizzes.